Hello there. In this video we'll be evaluating the sum of the series. What you see here on the screen, the summation in bracket to the power of 2n plus 1 the whole over 5 the power of n minus 1. N starts from 1 to infinity. Okay, this series, it has to be convergent, of course. So let us try to recall the convergent series rules and some properties. In case of convergent series, if you can write the bracket part in the form of a over b the whole the power of n, which is n starts from to infinity. In this form, if you can simplify and write it in this form, try to check the one which is in the bracket a over b. If it can be found between -1 and 1, that means if -1 is less than this a over b, if it is less than 1, we can apply the formula g1 over 1 minus r. The g1 and the r will be the one which is found in the bracket, obviously. By substitution you can check. So in case of infinite series, once it can be simplified in this form and written, and if the a over b, the one which is found in the bracket form, in the bracket, if it is found between -1 and 1, we can apply the g1 over 1 minus r. It converges to that. So our series here, the one which is found in the bracket, it's not written in the form of a over b. So what am I supposed to do? Okay, let us try to manipulate the one which is found in the bracket to the power of 2n plus 1 over to the power of n minus 1. I mean 5 the power of. So this is exponential, so we need to apply some exponential rule here. We can write the numerator part to the power of 2n times to the power of 1, the whole over the same manner 5 the power of n times 5 the power of -1. So what I did here, a the power of m plus n, if you have, you can write it a the power of m times a the power of n. Exponential rule. This is product rule. We call it product rule, the reverse process. The same manner for the denominator, because it's minus, so I can detach. Then 5 the power of -1, it can be taken up, because the exponent negative, you can bring it up. So this is the same as, it will be multiplied with 2 because constant, both of them are constant, 10 times 2 the power of 2 the whole the power of n the whole over 5 the power of n. I can write it in this way. What did I do here? We can again write this one in the form 2 the power of 2 the whole, because there is a rule again, a the power of m the whole the power of n is the same as a the power of mn, or you can write it a the power of n the whole the power of m form. So when you have two exponents, which is product here to n there is, you can write it as you like, mn or nm, or one inside the bracket, the other one outside. What I'm trying to do, okay, just to simplify and write in the form a over b the whole the power of n form. So what am I going to do now? This is equal to 10 the power of 2 square means 4 the power of n over 5 the power of n. Okay, awesome. Let's get back now. Let us remove this area. Let's clean it. Now what I can do, look, the last step where we stop, 10 times we said 4 the power of n over 5 the power of n. Don't worry about the 10, it's a constant, we can extract later on. So this one again, it can be written 10 the times 4 the power of n over 5 the power of n. It can be written 4 over 5 the whole the power of n. Very good, this is what we were looking for. So now our sequence, or I mean our infinite series, can be written the summation. Okay, first of all, yeah, the summation, I can say the summation 10 times 4 over 5 the whole the power of n. N starts from 1 to infinity. Okay, it's nicer now because things are now simplified. We can proceed to the next step easily, because the constant 10, it can be extracted out of the summation because it doesn't have any effect. So we can write it 10 times the summation 4 over 5 the whole the power of n. N starts from 1 to infinity. Now remember what I told you before, the one which is found in the bracket part, it's less than 1. 4 over 5, it's less than 1, between -1 and 1, of course, because here is the same as 0.8 nearly. So we can apply now the formula. So that means the 10, keep it outside. It's the same as G1 over 1 minus R, we said before. The G1 and the R will be the one which is found in the bracket. So we can write 10 times, the G1 is 4 over 5, the whole over 1 minus 4 over 5. Okay, we are here. So the whole game is found on the exponential, the upper part. Mostly the games are there. So this is the same as now again. Let us simplify again. Let's continue. In bracket, what we have, 4 over 5, the whole over. When we subtract this by crisscross, 1 times 5, 5 minus 4, which is 1 over 5 we do have. Okay, no need to bracket. But there are two fractions, up and down. So what I can do now, 10 times, 4 over 5 multiplied with the down fraction will be flipped, 5 over 1. Then you can cut here 5 with 5. And then what left? Just 40. So the answer will be 40, which is A. Thank you for watching.